Oh, it's late here. It's very late. I drive a lot to reach Catania from Campobello, but still, even if I'm a bit tired, I want to make this video about using Claude Sonnet and DeepSeek Coder, to compare the two, to write some code. So other than comparing these two very good large language models as coding aids, we will also cover the workflow that I have with interacting with LLMs when the task at hand is writing code. Keep in mind that I didn't prepare this video, so whatever happens. I will just follow my normal schedule, my normal way of interacting with LLMs and code. As a code base for our experiments, I will use the Kilo editor. Kilo is a very simple editor in less than 1,000 lines of code that I wrote in 2016 here and never touched it again. So everything, all the bugs that I introduced in the first version, I never fixed them. So this will also be interesting from this point of view. Kilo, okay, I will show you Kilo. It looks like a true editor. This is, we are inside Kilo reading the source code of Kilo here. Okay, let's quit. For example, the Kilo editor has a bug that I'm sure exists in this function. This function basically take a row number and then completely removes a row. So it takes the pointer starting with E is the global state of the editor plus the index, and then it free the row and then move all the pointers in order, to fill the gap. However, here is the bug. For each line, for each row which is following the deleted one, this should be E row j index minus minus. We want this row is logically one index less. IDX is the structure field which tells in which row is this row. So each row is a row in the file, and it's from line 0 to whatever. So this is the line 0 based. But let's leave the bug as it is. Let's start with Claude. So my workflow is basically not to use Cursor AI or something like that. I just have the web interface, and I drag and drop files here. Okay, this is a very important thing. When you drop one file, C file like I did right now in Claude Sonnet or in DeepSeek version 3, the whole file is part of the prompt. So it's seen by the context window of the model. Instead, in ChatGPT, they use RAG. So the files are just used by a tool that will extrapolate slices. For example, yesterday I added a PDF file and then a C file in ChatGPT, and he was not able to see anything. Then I pasted the prompt inside the prompt, the whole C file, and it started to work. Okay, so I pasted this file here, and I will ask, sometimes the editor that I attached here crashes. I believe there is some issue with the main functions used to manipulate the text. Please start listing the functions that are the most critical and may lead to some segmentation fault. Okay, let's start with that. This is Claude Sonnet. I will analyze the critical functions and blah blah blah. Edit row insert char. Yes, that's a critical function. There is a realloc. update row, insert row, row to string, del row. Exactly. Editor del row issues performs may move without proper bound checking, could cause issue if at is greater than not the number of rows, but these things are all checked internally. So yes, there is no safety here, but okay. Can you do? I could ask here if you do an analysis of each of these functions, but we would waste a lot of time. So I will ask directly, please can you do a very detailed analysis of each line of editor del row to see if there is some bug? Okay, here there is a bug. No, he missed it. I believe that he missed the real bug. Editor the row, so here wrote this function here, but the bug is still exactly there. So it failed in this test. Now let's try DeepSeek Coder. Drop the same file. Of course I will cut and paste the exact same prompt, because otherwise it's not fair. Let's see the replay with DeepSeek. It's a relatively simple text editor, and while it's designed to be robust, there are several functions that could potentially lead to segmentation faults. Blah 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 blah. Okay, editor del row. Okay, same stuff. Then what I did ask, yeah. Okay, let's ask this question. Let me move. Okay. Fix and join no is greater than 0. Purpose updates the edx field on each row after the deleted row to reflect the new position. Potential issues, blah blah blah, will be -1, and the loop. No, he didn't catch it as well. Final version. It's exactly the same issue. Okay, now if I ask let's ask a more precise question just to see if it can fix it this way. Make sure that there is the invariant that the row at row E has edx set to E. So I'm giving here a much stronger invariant to check inside the code. After deletion, verification, potential issue, conclusion. No way, completely missed it. Let's see if Claude is able to spot this. Yes. Now you see more powerful large language models are the improvement over a good language model is very subtle. This is exactly the kind of stuff that it's interesting. Analyzing the code, I noticed that the index update loop is actually wrong because it's incrementing indexes when it should be setting them to match their position. Let me fix. And yes, changed from idx++ to okay, it changed it in another way, but yes, now it's correct. There is a simpler one-line fix for this function. Oh yes, looking at the code again, since we are using memmove, we can update indexes exactly. Simpler fix. It is perfectly right. Instead of incrementing or decrementing, we know that the row of j will just be at index j. So yes. Okay, so Claude was able to do that. Very well. So let's delete this and let's delete this and go to the next question. Okay, basically if you check the Kilo editor, it's able to perform syntax highlight, but the syntax highlight, okay, this is for C++, C extensions and C keywords, and then there is the comments. I want it, but if I open with Kilo work vector sets test.py, there is no syntax highlight here because it's a Python program. So I will try this simpler thing. Let's drop the same file. Please, could you add syntax highlight for Python as well? Certainly, blah 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 blah. Python. Okay, and it added the Python stanza as well. Let's copy this. And then this one. Okay, make. Oh, that's super nice. Class vector, def, blah, blah, blah. Yeah, we have syntax highlight. You know, for this kind of things, it's a no-brainer. Completely a no-brainer. And it works very well. But now we have to do the same thing with Claude Sonnet. But if DeepSeek can do it, Claude Sonnet very likely can do it very well as well. But we will try the same prompt. And then I will show you something more hardcore. Let's see the differences in the implementation of this. Okay, it's a bit more complete perhaps. There are more stuff here. Yeah, more keywords, built-in functions and types, and also Python built-in exceptions. Other than the exceptions, it's very similar. Okay, but this was very super easy. Let's do another experiment. HNSW PDF. Okay, this is basically the data structure paper, the original paper of the data structure in order to create vector indexes. Let's upload it also in Claude. Why it is slowness? Okay, this is 2.5 megabyte file, so it's large file. And then we will open my implementation of this data structure, and also here I will paste here, and I will ask the same exact prompt. Compared to the paper, what are the extensions to the algorithm made by the C implementation I'm showing you, and analyze these changes that we are going to buy for a large amount of money. You know, with this kind of deconditioning clues, we avoid that the model will reply, oh no, it's fine, but we are putting pressure in the model saying that it should reply in a very conservative way. Like this change that we are going to buy for a large amount to understand if they are well designed. Okay. Let's see, I'm curious. And also, let's give the same prompt here. Let me analyze the key extension, measure extensions. True deletion support the C implementation as true element deletion capability, not just marking as deleted. This includes proper bidirectional link cleanup, which is true. Relinking orphan the nodes after deletion, which is true. Smart neighbor recognition using a sporing matrix. Direct within distance, but is no average distance. This is all true. This is a significant and well-designed enhancement that maintains graph connectivity after deletion, use sophisticated scoring system. Second, vector quantization. Quantizes vector from max up to store quantized range per vector, implement optimized dot product. This is also well designed. The threading model is carefully designed. Analysis of overall quality. The extensions are well thought out and professionally implemented. Code includes thorough error checking, edge cases, performance optimized, blah 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 blah. Okay, let me know. This change significantly enhanced the practical usability of the algorithm while maintaining its theoretical properties. The implementation quality suggests this will be a good value purchase. Okay, so I will buy it. Okay, let's see if also DeepSeek version 3 was able to identify the same features of the C implementation. Bidirectional links and non-deletion. Bidirectional links, non-deletion, the ability to delete. Notice significant improvement over the original algorithm, which does not address deletion. The implementation does deletion. The complexity could be a performance bottleneck in large graphs, especially if deletion are frequent. So this is a fair observation, but here the model failed to observe that removing the element and re-adding the element is more costly. Quantization and normalization. Analysis quantization is well-known technique, blah blah blah. Normalization, heuristic for neighbor selection. Okay, this is an extension that Claude failed to identify, actually. The C implementation uses a heuristic for selecting neighbors during node insertion. This heuristic ensures that a new node is connected to diverse neighbors. Blah, 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 blah. There is well designed. This is particularly important. Yeah, there is the heuristic also in the original paper, but in order to, in certain edge conditions, I extended the algorithm. Aggressive link strategy, concurrency and thread safety. Serialization, okay, this is also important. The implementation provides function to serialize and deserialize the HNSW index. Analysis well designed because it allows the index to be persisted and reused across different sessions. This is particularly important for large-scale applications where building the index from scratch will be prohibitively expensive. So, you know how much useful are these models. This is very key insights that you avoided to study and check inside the code, losing hours of your precious time. The bug, in conclusion, the extensions made by C implementation are well designed and as a server package. However, some of these extensions, such as node deletion and aggressive linking, could introduce performance overhead in certain scenarios. Therefore, it is important to carefully evaluate the trade-offs. Actually, these things save time most of the times, but yeah, it's a complex trade-off to analyze. Overall, this implementation is robust and well thought out extension of the original blah blah blah, and the changes are worth the investment if they align with your application requirement. Okay, I don't know how long this video is, but it's long enough, and I will make more videos like that. This is just a start. Bye.